Machines. You've been using this language every day of your life. Machines, machines, machines. But the question is, what is a machine? I want to bring that to you now. When we talk about machine, it simply means that particular device that will enable a smaller input of work or force to overcome a greater input of force. The smaller input, which we call an effort, to overcome a greater output there, which we call the load. Examples of machine: your screw jack. If I ask you to lift a car to fix up your tire, it becomes almost impossible, my dear. But if I ask you to use your screw jack to lift up the tire and do whatever you want to do, imagine you're taking a mineral and using your hand to open the cork. It becomes almost impossible. But with your mere opener, a little input can overcome that greater output that you cannot use your hand to do. And those are machines. Anything that will aid us and make our work easy, enabling us to use a little input to overcome a greater output, is called a machine. Now, on machine, we have some physical parameters that we have to discuss. The major one there is the mechanical advantage, then the velocity ratio, and the last one we talk about the efficiency. Now let's talk about mechanical advantage. When we talk about mechanical advantage, or another name as implies, force ratio, it simply means the ratio of the force output to the force input. That means my force output is the load and the force input is the effort. So mechanical advantage, MA, is load all over effort. This is the mathematical definition of mechanical advantage. Then velocity ratio, as the name implies, it simply means the ratio of the effort distance to that of the load distance. For example, if you have this to be a truck somewhere here and you want to carry something from here into the truck, now there is a certain distance of the load and the effort. Or if I have this now coming down, and this is what I have, this is my load and this is the effort. For this to go down, then this will come up. If this is going down, it is covering a certain distance, which is called the effort distance, ED. And this is coming up, which is covering the load distance, LD. We now say that velocity ratio is equal to effort distance all over load distance. From there, we take on the third one, efficiency. So let's look at efficiency, which is the third parameter I want to discuss. As I said, efficiency is not the same as accuracy. In the world of efficiency, or in the world of physics, we say that efficiency has to do with the work output with respect to the work input. The ratio of the output to the input, whether it's high or low. So defining efficiency, we said, is the percentage ratio of the work output to the work input. That means efficiency E is equal to work output all over work input times 100%. That is what we mean by percentage ratio. If I'm bringing this down further, which I would like you to do, my dear, try bringing your work output and bringing your work input, which will have, my work output will be the load times the load distance, because work is force times distance, while my work input is effort times effort distance, all times 100%. Now taking this the way it's supposed to be, you know that load over a load to effort, look at it there, is mechanical advantage, and load distance to effort distance is the inverse of velocity ratio. So that means that efficiency is equal to load over effort times load distance over effort distance times 100%. This one is mechanical advantage times load distance over effort distance is the inverse of this one, which is 1 over velocity ratio, then times 100%. Bringing it over here, we have it that efficiency is equal to mechanical advantage all over velocity ratio times 100%. And this is a wonderful equation that you must look out whenever we talk about machine. In summary, even if you are forgetting anything, don't forget the equation of mechanical advantage. We say that load over effort is equal to the mechanical advantage. Is the mathematical definition of mechanical advantage. Then velocity ratio, effort distance over load distance is equal to the velocity ratio. Then work output over work input times 100%. This is also very important. And then finally, the most important equation of machine, which is efficiency, equal to mechanical advantage over velocity ratio times 100%. My dear, I would like you to do me a favor. Go down now and write 20 examples of machines for me and be able to manipulate these things in calculations immediately. Thank you, and meet me in the next topic that we are heading on to now, which is current electricity.